So on this question, we want to use calculus techniques for curve sketching on this function f of x equals x cubed plus 4x squared minus 4x minus 16. So the first thing we're going to do is calculate the derivative, which is 3x squared plus 8x minus 4. And we will set this derivative equal to 0 to find the critical numbers. And let me see if I can factor this. There would be 3x and x. I could try 2 and 2. That's 2x and 6x could make 8x, with both of them being positive. Okay, let me check. Okay, so that factorization is not going to work because we would need pluses to make the middle term right. We need minuses to make the last term right. So that factorization is not going to work. And I'm going to go ahead and use the quadratic formula to find these critical numbers. So we're going to let A equals 3, B equals 8, C equal -4, and we'll use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. That's x equals -8 plus or minus the square root of 8 squared minus 4 times 3 times -4 all over 2 times 3. And that's going to give me -8 plus or minus the square root of 64. 4 times 3 times 4 will give me 48, and that'll be a plus. 48 plus 64, 112. -8 plus or minus square root of 112 over 6. And if we type those in our calculator, we're going to get approximately -8 plus square root of 112 over 6 is approximately 0.4, and -8 minus square root of 112 over 6 is approximately -3.1. So these are our critical numbers that we got from calculating the first derivative. These are going to give us horizontal tangent lines. And we're going to place these critical numbers on the number line in order from smallest to largest. And what we want to do is pick test points in each one of these intervals to see if they come out to be negative or positive. And the ones that come out negative are going to be intervals where the function is decreasing, and the ones that come out positive are going to be intervals that are increasing. So let me pick test points in each one of these intervals. So I'll pick -4, 0, and 1. And we want to substitute those into the derivative. So into the derivative, I'm going to substitute these test points of -4, 0, and 1. These are some calculations that I've done earlier, so Once you substitute them into the derivative, this is the key part, substituting into the derivative, you'll get a positive 12, a negative 4, and a positive 7. So we get in that first interval positive, and the next one negative, and the next one positive. So what that tells me is that on that interval, the function is increasing, decreasing, and then increasing. So now I know that this function will be increasing from negative infinity to negative 3.1, union with 0.4 to infinity. So I took those two positive intervals, and decreasing from negative 3.1 to 0.4. But not only that, from building this chart, I can tell where the extrema are for this function. Extrema would be a relative max or relative min. So I'm going to erase this bit about increasing and decreasing. And now think about this in terms of the relative min and max. So when a function goes from increasing to then decreasing, that creates a peak, which is a relative max. And then when the function goes from decreasing to increasing, that's going to create a relative min. So I know, based on that chart, that there is a relative max at x equals negative 3.1 and a relative min at x equals 0.4. Now, when we get to the point where we're going to sketch the graph, I need the ordered pair and not just the x-coordinate. So I would take these values. These are my critical numbers that I'm going to substitute into the function. Critical numbers of negative 3.1 and 0.4. We're going to substitute those in and get, these are calculations that I did earlier, 5.0 and negative 16.9. So once again, I'm substituting those into the function. You notice the difference? We substitute in the derivative, which was going to tell us increasing and decreasing. We substitute into the function when we want the ordered pair that's on the graph. All right, so we're going to continue to use the calculus techniques to find out information about the function. And we found out everything from the first derivative, and now we're going to find out information from the second derivative. We have already calculated the first derivative to be 3x squared plus 8x minus 4. And we're going to calculate the second derivative, which is 6x plus 8. We're going to find the critical numbers from the second derivative by setting it equal to 0. I subtract 8 and get 6x equals negative 8. Divide by 6, and x equals negative 1.3. So the second derivative is going to tell us about the concavity, which is the shape of the curve. So we're going to build our chart with that critical number of negative 1.3. I want to choose test points in each interval. For my test points, I'll choose -2, and 0. And we're going to substitute those test points into the second derivative. So we have test points of -2 and 0 substituted into the second derivative. These are calculations I did earlier. We get -4 and 8. So in this interval here we have concave down, and this one concave up. So when we get a negative, that tells us concave down, and a positive tells us concave up. So this interval is concave down. This one is concave up. So the function is concave down from -infinity to -1.3, and it is concave up on the interval -1.3 to infinity. So not only that, we discover a very important point called the point of inflection. And the point of inflection happens when there is a change in concavity. And we have a change in concavity at -1.3. So that gives me a point of inflection at x equals -1.3. And later on, when we get to graphing this, we'll need to know the ordered pair. So we're going to take that critical number of 1.3 and substitute it into our function f of x. And that will give us the point of inflection -6.2. And I made a mistake here. That's a -1.3. So we have the ordered pair of -1.3, -6.2 being the point of inflection. So that's the extent of the calculus information we're going to get. There are a few pieces of algebra information that will be helpful. So looking at our function, f of x equals x cubed plus 4x squared minus 4x minus 16. I'm going to get the x and y intercepts. So y-intercept is a little bit easier. We're going to let x equal 0. So f of 0 is 0 cubed plus 4 times 0 squared minus 4 times 0 minus 16. So -16. And we have the ordered pair 0, 16 being the y-intercept. Now I can also find the x-intercept by letting y equal 0. That's f of x equals 0. So I set the whole function equal to 0. 0 equals x cubed plus 4x squared minus 4x minus 16. I can solve this by factoring. Factoring by grouping. I'm going to group these two terms together and factor out an x squared. I'll be left with x plus 4. I'll group these two terms together and factor out a -4. That leaves me with x plus 4. I have a common factor of x plus 4 that I can factor out. And I'll be left with these coefficients of x squared minus 4. And x squared minus 4 can be factored more into x plus 2, x minus 2. So that's going to give me x-intercepts of -4, -2, and +2. All right, so I have a summary of everything that we found in this problem. We have intercepts, the increasing, decreasing, the relative extrema, the concavity, and points of inflection. We're going to use all of this when we draw our curve. But before we do that, I want to talk about some nuances of how to draw the curve in certain spots. So this relates to the concavity. So we have for concavity, I'm going to draw an up-facing parabola and a down-facing parabola because they give us a really good example of how to draw the different types of concavity. So along this portion right here, on the up-facing parabola, we have decreasing, and an up-facing parabola represents concave up. On this portion of the parabola, the graph is increasing but concave up. So this should say increasing. And then the down-facing parabola is concave down. This portion is increasing, but concave down. And let's get one more color there. Purple. On this section, we have decreasing and concave down. So if we compare the two decreasings to each other, you can see that decreasing concave up and decreasing concave down have a slightly different curvature to them. And the same thing with increasing concave up with increasing concave down. So I want to distinguish which parts of our graph have this type of curvature. So what I'm going to do is I'm going to make a chart, and on this chart I want to put the critical numbers from the first derivative and the critical numbers from the second derivative. So from the first derivative we had critical numbers of negative 0.3, 1, and 0.4. And for the second derivative we had a critical number of negative 1.3. So I'm going to put those numbers on the chart. That's negative 3.1 and 0.4 and negative 1.3. And on this chart, what I want to do is I want to write down what happened with the first derivative and also what happened with the second derivative. And let me draw it going like this. And I'm going to draw going up here and up here. So I'm going to pay attention to every single one of these intervals. Now, to the left of 3.1, we had increasing, which means that the first derivative was positive. And to the left of 3.1, we had concave down, which means the second derivative was negative. Then from 3.1, on this section here, from 3.1 to negative 1.3, we had the first derivative being negative because it's decreasing. And we had the second derivative being negative. because it's concave down. And then from 1.3 to 0.4, so 1.3 to 0.4, the first derivative said decreasing, so that means it is negative. And the second derivative, so from negative 1.3 to 0.4, the second derivative was concave up, which is positive. And then we have from 0.4 on, it's increasing and also concave up. So increasing and concave up. So my negatives and positives, we've got a negative for the second derivative is concave down, concave down, concave up, concave up. For the first derivative, we have positive being increasing, negative being decreasing, and decreasing, and then increasing. So what I wanted to do with this is figure out which one of these curves we'll have in each one of these intervals. So if we have on this first one here, talking about this one right here, let me fix that. We have increasing concave down. Increasing concave down matches that curve that we saw over here that was like this. Matches this curve right here, which is like this, increasing concave down. Then on the next one, we have concave down decreasing. Concave down decreasing was what I drew in purple, like this one. And then we had decreasing concave up. Decreasing concave up is what I have in red here. And it looks like this. And then in that last one, we have increasing concave up. And increasing concave up is like the one I have in blue here, which looks like this. This is going to help us draw the curve if we know the curvature. Alright, so let's sketch a graph of this curve with all of this summary information. So I'm going to use my intercepts, relative extrema, and points of inflection to put on the graph first. So my intercepts, my x-intercepts are at -4, -2, and +2. I have -4, -2, and +2 for my x-intercepts. And my y-intercept is -16. So I don't want to draw 16 tick marks, so I'm going to count by 5s. So 5, 10, 15, 20. So these are going by 1s, and these are going by 5s. So my y-intercept is at -16, so that will be about here. And then I'm going to start drawing the curves. Oh, sorry, I need my points of inflection and my extrema. So that's going to be at -3.1 and 5. Remember, I'm counting by fives on the y scale. So let's say 5, 10, 15. So -3 and 5 would be about here. -3.15 would be about here. And then 0.4, -16.9 would be about here. And then I have a point of inflection at -1.3, -6.2. -1.3 and 6.2 would be around here. So starting on the left, I'm starting with this section right here. This part tells me how to draw the curve all the way up to -3.1, which is right here. So leading up to that curve, I'm drawing it increasing but concave down, cupped down. And then this section is how I'm going to draw the curve from -3.1 to -1.3. -1.3 is that point of inflection, which is right here. So I'm drawing it decreasing and concave down. And let me correct that because I need to go through the x-intercept as well. And then on this portion here, from -1.3 to 0.4, I'm going to draw it this way. And 0.4, remember, is that relative extrema, that relative minimum. So we're going to draw it decreasing but concave up. And then our final section, we're going to draw this way. This is increasing concave up. And we now have a sketch of our graph. And our sketch of the graph is of the function x cubed plus 4x squared minus 4x minus 16. Thank you for checking out my videos. Have a great day.